Hi, welcome to Hunter Engineering Company. My name is Dave Scribner, Product Manager for the GSP 9700 and other wheel balance related products. I'd like to take a moment and thank you for choosing the GSP 9700 vibration control system. The 9700 is not only a fantastic wheel balancer, but it's revolutionizing the industry with its ability to also locate and repair non-balance related tire and wheel vibrations. Because of this, we'd like to take a few minutes and review some very important operational guidelines. Although we're focusing on the GSP 9700, many of these guidelines apply to any wheel balancing operation. As an outline for this program, and as a reminder to use at a later date, we're going to use this placard, which is included with every unit. We suggest that you attach this placard to the 9700 for future reference. Over the course of this program, we will discuss wheel centering, proper balancing techniques, tire inflation, road testing and tire warm-up, tire mounting techniques, what to do when road force measurements are exceeded, proper use of road force limits, centering the wheel on the vehicle, and basic maintenance and calibration. To ensure accurate measurements, the wheel has to be mounted properly. In order to have the wheel mounted properly, it must be centered on the shaft and clamped flush against the hub face of the balancer. There are a variety of adapters available: cones, spacers, flange plates, and chucks. The main purpose of all these adapters is to mount the wheel centered on the balancer. There's all sorts of different ways to mount these adapters, and for additional ideas and tips, consult the operator's manual. Pick the adapter that best fits the wheel, and then make sure that you securely tighten the wing nut. This is a special wing nut designed to increase clamping force for road force measurement. Don't use anything else. If the mounting is questionable, there are two ways to check this. First, a manual method using wheel weight. The wheel is measured in one position, the wheel weight's recorded, the wheel is then repositioned and spun again, and the difference in the wheel weights required are compared. The second method, called centering check, is a feature of the GSP 9700 and uses runout in order to verify that the wheel is centered properly. First, place the inner arm against the outermost rim edge as shown. Press start to measure rim runout. Place the valve stem at 12 o'clock and press K4 to store the location. The next step is to loosen the wheel and reposition it along with the cone to a different location on the shaft. Retighten the wheel and measure rim runout again. As a last step, store the location of the valve stem again at 12 o'clock. And now we can determine if the wheel is centered or if there's a problem that's been detected. Details describing the procedures and others that will be covered in this presentation can be found in the enclosed operator's manual, the Rolling Smooth training manual, and video. Live training and seminars are also available through your local Hunter representative. With some exceptions, we recommend that you avoid static, single plane balancing even when customers do not want a weight on the outside of the wheel. This is why. Commonly, static balancing is done with a clip-on weight attached to the inside flange of the wheel. The static imbalance may be zero, but the dynamic imbalance or wobble in many cases is made worse. To properly static balance a wheel, the weight is attached as close towards center as possible. By doing so, the dynamic wobble is not affected, but the static forces are reduced. Obviously, the job is not complete, however, if this is the only balance method chosen. The proper way would be to do a dynamic balance using two weights in separate planes. For instance, if the customer did not want any weights on the outside of the wheel, you'd place a clip weight on the flange and a tape weight as far away inside the wheel as possible. This will cancel the static forces up and down and also solve the dynamic wobble imbalance side to side. This is the best type of balance that will minimize ride disturbances. With today's technology, it's incredibly simple to do a hidden two-plane dynamic balance. Let me show you. Choose the Mixed Weights button and select the type of balance you'd like to perform. On this particular wheel, we're going to do a clip weight balance on the inboard flange and a tape weight on the furthest outboard location inside the wheel. Choose the picture and then pick up the inner arm and touch it to the location of where you'd like to place the clip weight. Store the information and do the same for the tape weight. As you can see, all we do is position the wheel so the clip weight now is at top dead center. And then without even recalling where we measured to place the inboard tape weight, just raise the arm, place the tape weight into the clip holder, and just run it out until the weight can be applied against the wheel. It's just that simple. Before measuring road force, it's very important to set the tire pressure to the manufacturer's recommended specification. These specifications are not the maximum load range as indicated on the tire, but can be found on the driver's side door pillar. One of the first and most important measurements of the GSP 9700 is road force. However, there are two types of tire flat spotting which can affect our measurements. First, temporary flat spotting should not be measured if at all possible. Permanent flat spotting should be measured. Permanent flat spotting can occur, for example, if the tire locks up and slides down the road for a long distance. Another form of permanent flat spotting can be when tires are stored improperly in inventory for a long period of time. Unfortunately, when the vehicle is driven, permanent flat spots do not diminish. They tend to remain the same or actually get worse as the tire is warmed up. Temporary flat spotting can occur if the vehicle is parked for an extended period of time. Extreme hot or cold conditions can also accelerate these effects. High-performance tires with nylon plies, bias ply tires, or off-road tires are also susceptible to accelerated temporary flat spotting. It's important to remember that by driving the vehicle to warm the tires, temporary flat spots will diminish and go away. Since we do not want these temporary measurements to affect our readings, a road test tire warming exercise may be necessary prior to road force measurement. Tire and wheel technology is always changing to meet the evolving needs of today's vehicles. For example, when you're mounting tires, have you noticed now that when the bead seats, it pops and sounds like a gunshot? The reason this is that the tire tolerances and wheel tolerances are now being made tighter to ensure that the tire doesn't change position on the rim during heavy acceleration, braking, or cornering. Because of these tighter tolerances, it's very important that you use sufficient lubrication on the tire bead and the rim and use proper mounting methods. If these are not followed, you may have non-uniform fitment between the tire and the rim, which can cause problems with ride quality, road force measurement, and balancing. Anytime road force limits are exceeded, there are a variety of options that may be taken. But first, be sure that the limits that you've chosen are reasonable for the sensitivity of the vehicle. For example, if you're measuring a large light truck tire, don't compare those measurements to very low passenger car limits. If the limits that you've chosen are reasonable, the most important thing that you should do first is measure rim runout. Measuring runout is the only way to determine if force matching is a solution. When measuring the rim, the GSP 9700 calculates lateral and radial runout. In order for these measurements to be accurate, it's very important that you place the arms at the correct location on the wheel to measure the rim properly. The inner dataset arm is placed here, directly below the outermost edge. Pick the best location on both sides of the wheel that approximate the area where the bead of the tire sits. If the rim runout turns out to be very low, force matching may not have much benefit. But it's still important at that point to remove the assembly from the machine, loosen the tire bead, lubricate the tire and the rim, and reinflate it. This will assure you when you remeasure that there is not a tire to rim mounting error that can be contributing to this condition. In fact, in many cases, just by simply loosening the tire and relubricating and inflating, this high force variation will disappear. There are two other features on the GSP 9700 that can aid you through these processes. First, match code will allow you to determine the contribution of the tire and the contribution of the wheel to the assembly force. When you're working with sets, Matchmaker is a second option that can be chosen as a guided procedure, working with a set of tires and a set of wheels to mix and match them to find the best possible match. For additional information on these two features, consult the screen prompts or take a look at the operator's manual. Road force limits are simply guidelines used to flag for potential problems. There are also reference points that we use to create diagnostic messages. For instance, the GSP 9700 is programmed from the factory to have a default limit of 26 pounds for passenger cars and 36 pounds for light trucks. Of course, some vehicles are more sensitive than others. For instance, a vehicle may be affected by 15 pounds of assembly force. On the other hand, some vehicles, such as a larger light truck, may be able to tolerate 45 pounds and beyond. Since road conditions, customer expectations, and vehicle sensitivities differ greatly, road force limits should never be used as an absolute. A tire or wheel may be over the limit and not be causing a problem. The only way to confirm A remaining concern that you may have of the assembly is to road test the vehicle. This wheel has been measured and balanced centered on a wheel balancer. When it's mounted on the vehicle, it should also be centered. If it's mounted off-center, as the wheel is rolling, the balance and road force conditions will differ. Improper wheel to vehicle centering will cause vibration. To help ensure that this wheel is mounted properly, follow these basic tips. First, be able to identify a hub-centric wheel versus a lug-centric wheel. This is a hub-centric wheel. With the lug nuts removed, I am unable to move the wheel up and down and side to side. When there is no perceptible movement, that is a hub-centric wheel. These are the most common and less likely to cause centering error. However, it's still important to tighten the lug nuts in a star pattern and always to finish the job with a torque wrench. Okay, here's a wheel that looks identical, but it's not. This wheel is lug-centric. How can you tell? Well, you're going to have to mount it on the vehicle. When I place the wheel on the hub, it's no longer a slip fit. In fact, if I move it up and down or side to side, there is perceptible movement. This is a lug-centric application. Lug-centric applications are extremely sensitive to centering error. Here, it's very important to make sure that you tighten the lug nuts in the star pattern while rotating the assembly. Make sure that there's minimal run out during tightening. When you're done, as usual, make sure you torque the wheels. For additional information on how to diagnose wheel to vehicle centering errors, consult the Rolling Smooth training manual. Anytime you notice the wheel requires a second or third weight application in order to get the wheel balanced, it may be a good time to check for calibration. Quick Cal Check is a procedure that's fast and simple and allows you to check calibration anytime during operation. Just press reset twice and select from the wake-up screen. Remove the calibration weight and install it on the faceplate in either hole on either side. Close the hood and press start. If quick calibration passes, it will display ready. It's also important to check the weight angle position by positioning the weight so the arrow turns green and verifying the proper location of the weight. If calibration check fails, go back to the wake-up screen, hit the shift button to the second level, and choose Calibrate. Begin by selecting Balancer and just follow the screen prompts. It's very simple. This may also be a good time to check your adapters and your cones for wear, nicks, and burrs. Lubricate the shaft of the balancer, but keep the faceplate completely dry, making sure that there's no nicks or burrs or debris on the faceplate. Maintenance and calibration is very important to make sure that your measurements remain accurate. Your company has invested in the GSP 9700 to be absolutely sure they can offer the best possible balancing job to your customer. And through your operation expertise, you can help ensure that this happens. But when you have concerns, always use this placard. This way you can be sure of what you should be doing and what you should not be doing. In fact, if you get in the habit of following these recommendations, eventually it's going to become second nature. For anything that you're not quite sure of that's not on this placard, Also, remember that you can refer to the operator's manual for the GSP and the Rolling Smooth training program. You can also seek assistance for local training from your hunter representative. This will help guarantee that you'll become the best in the business. Being the best in the business will help your customer, your company, and increase your value as an automotive technician. Thanks for watching this video.